In this video, we will discuss about the transmission line modeled as a two-port network. We know the transmission line is a model of distributed inductors and resistors over a long distance and shunted with ground with a capacitor and conductance. Conductance will of course model the corona loss, capacitance will model the charging current, and in the resistor will model the voltage regulation. Now if we consider this transmission line as a black box like this, all four parameters will considered as a circuit and that circuit will be a black box, then we can draw the same circuit like this when we'll have this voltage, generation voltage or sending end busbar voltage, and same the receiving end current and receiving end voltage. We will have these four parameters and we can observe these four parameters will be dependent on each other. Their dependence will be linear because we have only linear components between the sending end and receiving end like inductor and resistor only. So we can develop some linear equations and then we can just express these four parameters with help of another four parameters. So we'll just take other four parameters like a, b, c, d, and their relation will be given by these two equations where a, b, c, d's are the parameters, and while in matrix form this will form like this. We'll have the sending end parameters modeled as the combination of transmission parameters and receiving end parameters. Okay, so by now we'll analyze this thing and we'll have this sending end parameters will be modeled like the transmission parameters and receiving end parameters, combination of these two. While analysis, the first condition of analysis will be with receiving end open. So we'll keep the receiving end open and therefore we will have the receiving end current equal to 0 and receiving end current equal to 0. Putting it in the first equation we will give like Vs equal to A VR, and A will be given by sending end voltage divided by receiving end voltage. This can be given by inverse voltage gain, or we can define this like only sending end voltage equal to A parameter into receiving end voltage. And the voltage regulation, then voltage regulation is given like voltage regulation equal to voltage receiving end voltage at no load minus receiving end voltage at full load divided by the receiving end voltage at full load, equal to, we'll put this VR naught from this equation, VR naught equal to Vs by A. So Vs by A minus VR divided by VR. This is the general formula and we can use this formula for anything, and if we have to find the voltage regulation in percentage form we can just multiply by 100. This will give the percentage regulation, this will give percentage regulation. Okay, the charging current, next will be the charging current. Now we have seen like this is the receiving end current is 0, but is not 0. So is where the receiving end, where the current is going, current can go only, we have modeled this thing like we will have some resistance, inductance, resistance, inductance, and in capacitor, in shunt with a capacitor. So the shunt capacitor IC, this IC current is given by VIS because current has no other direction to go. So it will be approximately equal to the charging current. Charging current will be approximately equal to the sending end current. Okay, thank you.